Subspace. In this video, I will tell you that how to prove a subspace. If any set is given to you, let W be a subset of a vector space V. The first condition here in it for proving it a subspace is that the given set must be a subset of a vector space. If it is a subset of a vector space, then we will proceed further. If it is not a subset of a vector space, then we will say it like, since it is not a subset of a vector space V, then this is not a subspace. So for proving the subspace, the first condition is, the necessary condition is that the W, the given set, must be a subset of a vector space. The first important thing is the W be a subset of a vector space V. And the second important thing is W is itself a vector space. If this axiom hold, and then prove the W by proving the axioms of a vector space. If W is proved that it is a vector space itself under the addition and scalar multiplication defined in the main vector space V, then we can say like W is a subspace of V. So what are two main conditions? The first condition is W must be a subset of a vector space V and prove all the axioms of a vector space for the W. It means W is itself a vector space, and under which operations? Under addition and scalar multiplication that is defined in the main vector space V. Then we can say like W is a subspace of V. Now, what is the necessary thing you have to prove in the subspace? The same thing that we proved in a vector space. You have to prove on the given set all the axioms of a vector space. If all the axioms of a vector space are satisfied for this W, that is a subset of a vector space V, then we can say like W is a subspace. So what are those axioms that you have to satisfy here? The first axiom is W is an abelian group under addition. Now the first axiom is you have to prove W as an abelian group under addition. And for proving it as an abelian group, there are 5 more axioms inside it. The first is you have to show that addition is closed. What does this mean that addition is closed? You have to consider 2 vectors from this given vector, and you have to show that their addition is closed. That is, their addition also belongs to this given set W. So it means addition is closed. The second axiom inside this abelian group is you have to show the commutative property. And what is the commutative property? Consider the 2 vectors from the given set W, add them in this manner and change their positions like this. If this condition holds, then this is commutative property holds. Now move on to the third axiom. A third axiom is related to the associative property. What is that associative property? You have to consider 3 different vectors from this W. Add them up in this manner. First of all, add V and W and then add it with U. This will give you the same answer if you add U and V first and then add it with W. The fourth property is additive identity. For additive identity, there exists 0 from this given set W such that if you add it with any of the vector from this W, it will give you the same vector U. Now the fifth property is fifth and the last property is additive inverse. For additive inverse, for each U belonging to this capital W, there exists negative of this vector such that if you add both of them, you will get a 0 vector in your answer. So if you proved all these axioms, then it means W is an abelian group under addition. Now, you have to move on to the second axiom for proving it as a vector space, and the second axiom is, let's suppose K is any scalar. K is any scalar, and you multiply it with the addition of two vectors from this main set W. It will give you the same answer if you multiply the scalar with the vectors separately and then add them up. The third axiom for proving it as a vector space is, consider two scalars, add the scalars like this and multiply it with a vector. You will get the same answer if you separately open it like this and then add them up. The fourth axiom is, if you have two scalars k and m, here you have scalar multiplication. First of all, multiply m with u and then the answer with k. It will give you the same answer if you both multiply the scalars and then with the vector. Fifth and the last axiom is, if you have identity in this main set W such that if you multiply it with the vector from this W, it will give you the same vector. So if all these axioms are proved here, then this means that this is your subspace. And how you can prove all these axioms? This method is given in a video for vector space. You can consult the video named as a vector space. You can see the example that I have solved in that video for the vector space. Follow that method and you can just solve all these axioms by following that video.